and have both turned in the report sheets. Number 5, make sure, take a photo of it, email it to me as soon as possible, just so that I can grade it as quickly as possible for it. Alright, you didn't have any other homework besides that, so we're gonna go ahead and start reviewing. We're not really gonna play a review game because it's been 3 days, and typically it's kind of struggling. So we'll just alternate back and forth between the 2 gentlemen in here. So Jamie and Quentin, try to hopefully try to jog your memory as much as possible. Now there's no quiz today, but tomorrow is fair game. So I go ahead and take out a piece of paper so we write down stuff you don't know. We've been talking about binary compounds.
Might as well just open the book so we don't have to write down all of it.
Right. And I hope you remember to study. Alright, so what do you call the study or the part of science that compares the numerical relationships between elements and compounds? So what do you call that? You know what? You can roll dice. Remember that even your way more, and I don't want them to blow out their eardrums, whatever they're doing. There, choose dice quickly.
Seventh graders taking to choose dice.
Okay, they talked about their STEM project today. Alright, so we'll just stick with Chris. Alright, Chris, what do you call the part of science that is the numerical relationships between elements and the compounds? Remember what that long word is?
Stoichiometry.
Stoichiometry. Alright, what do we call the symbolic representation that we use to specify the elements present in a compound and the relative number of those atoms? So if I were to write...
Wait, what? What's the definition?
What do we call this? So what do we call
Water.
this? What?
Water.
Okay, so whenever I write it out like this, like H2O, what do we call that? The symbolic representation of water.
What's it start with?
Technically, C, we just use F typically though to refer to it. What do we call this? Just saying what it is.
Give us a bad question to mine.
Okay.
The formula.
Formula or chemical formulas, but yeah, formula, chemical. It's been a while, it's okay.
Alright, you studied it.
It's okay. There are 2 basic types of chemical formulas, so that too, Ethan. Alright, if it's about a molecule, what type of formula do we use?
Molecular.
Good job, molecular formula. Alright, what is the type of formula that shows the simplest ratio? We don't use these for molecules.
Starts with E.
Starts with E.
Imperial.
I'll take it. Empirical formula. Alright, what is the one we use specifically for the ionic compounds? Because it is the empirical formula, so it's the simplest ratio. It's not ionic formula.
Wait, what?
It's not
Say it
ionic
again?
formula. What do you call it to where it is the empirical formula? We have a special name because it refers to specifically just the ion one.
What's
So
that?
like NaCl. It starts with A, F. Again, sorry.
Chris.
Alright, remember? It is the empirical formula, but we have a special name because referring to an ionic compound.
Is it weird name?
Sort of. Kinda.
Phineas.
Nope. Alright, formula unit. So write it down. Formula unit.
Philip
Alright.
starts with an F.
What?
Philip starts with an F.
Wait, what?
Philip starts with an F.
Alright, so what is, if we're talking about the prefixes, what is the prefix that means 1, Ethan? It's been a long week and I know.
What's start with?
What? M.
Mono.
Mono. Roll.
Mono.
Modo.
Mono.
Money.
Alright, great, roll.
Modo.
Alright, what means 2?
Starts with a D.
Starts with a D.
Die.
Die. Alright,
What I wanna
Ethan,
do.
what is 3?
Try.
That's it? Alright,
Triceratops.
4.
Uh,
You know why they call it Triceratops?
Because
Is
it
it
has
as blue
Eileen.
Horns. Okay.
Alright,
4.
starts with a T.
Yes.
Tetra.
Alright, 5.
Wait, what?
Yeah, what is the prefix that means 5?
P? It starts with P.
Yes, so P. Penta. Alright, 6.
Oh, so what's that?
H.
Hecta? No, hepta. No.
Hepta?
No. It's
You're like combining with both of them.
6.
Hecta.
Yeah, 6.
Say it one more time.
Hecta?
No.
He said hector?
Hector.
Hector. No.
Okay, you're going Hector?
No. Yeah, hector.
No. Alright. Hexa, H-E-X-A.
I can't pronounce my
Hexa.
8 and my
Yes.
X's.
Alright, Hexa. Alright, so back to you then, Chris. 7, what means 7?
Hepta.
That's Hexa.
No.
The P. Alright, 8 even.
Octo.
Yep.
Who? Who's Otto?
Alright,
You said
don't get too distracted, Chris. Alright, number 9. In. This is a little bit hard.
Nano?
Yep. And then, what is 10?
Deca.
What?
Yeah.
Deca. Alright, if you're going to name a binary molecule, let's see, we'll just grab one. So, if you're going to do this, alright, how would you name it? Let's start with,
Is that an R?
yeah, DR.
No, it's
Bromine dioxide?
Good job! So remember that first one, you just say just the name, and then the last one, you get the prefix. Alright, what if it's like this? Alright, Ethan, how would you name this one?
Dinitrogen
Good job.
dioxide.
Perfect. Alright, what about,
My deodorant makes me sweat.
good, Quentin and Jim, you probably don't want to know that. Alright,
SE?
yeah,
I don't remember what SE, but it's fluoride. It's tetrafluoride.
There. Sorry, Quentin, Jim, you can't see me.
Selenium?
Selenium.
Alright, selenium, selenium hectafluoride? No, selenium hexafluoride.
Hexafluoride. Alright, so, ooh, let's say it was diboron trioxide. So, diboron. Alright, so, how would you write this out? If it's diboron trioxide. Alright? Good job.
B.
Alright, what about tetrasulfur dinitride? So tetrasulfur.
3S3N2.
So tetrasulfur.
That's what you said, right?
Is this
You
tetra?
said tetra? I thought you said
Yes.
tri.
No.
Alright, 4.
Yeah, that's what I call them. I do it over and over again.
Tetra.
Alright, anyone have any questions? So like if your quiz tomorrow were to ask how to name stuff and how to write stuff out and what prefix means what, you feel okay about it? Or does anyone have any questions about it? Okay. It should in theory be an easy quiz. So it's one
In
of the
theory?
in theory
Everything besides
if
in
we
theory.
have the quiz tomorrow. It's one, but if you're confused on it, ask me today. We've done enough practice where I feel like okay, you should be pretty good with it. Alright. So Luke, oh that's right. Anyone have 15 or more?
I need to count.
Count.
I have
Alright, who's
48.
got? You have 48? Alright, everyone got 48 then? You got more than 48?
Chris probably wants to get 49 or something. Do what?
You can use a calculator in this class.
I like 4 8s, 5 8s, or something like that. 8
What did you say you had?
You said you had 48.
He beat me by 4.
Alright, so here's the rules. If you need to know what for naming a binary molecular compound, so the first element gets a prefix if it needs it, but other than that, it's just its name. Second element ends in I. It also gets a prefix if it needs it. Sometimes vowels are dropped to aid in pronunciation. Now, do you have to include mono, Chris?
Yes.
Depends on if it's the first element or the second element.
Not really, actually. Typically, because it's an understood one, you don't have to include it. It's okay to include it, but traditionally, we don't. Same idea that if you're writing off like this, we don't put a 1 down here because it's traditionally understood that, okay, if the symbol's there, then it's an understood 1 already, so you don't have to for that. Alright, we typically use this with non-metals. We talked about the reason why, so we're not going to go over that part again. Alright, anyone have any questions about naming binary molecular compounds? Alright. So, naming ionic compounds. So these are charges. So check it out, the formula unit can be thought of as the smallest division of an ionic compound. We talked about this with sodium chloride the other day. That sodium chloride, the sodium wants to lose its 1 electron. We'll talk about the reasons why in a couple of weeks. You just need to know that it wants to lose it. And so the chlorine wants to gain it. So the chlorine has a -1 charge around it. the sodium has a positive 1 charge around it. So they will actually align themselves and basically create this lattice work or this kind of alternating pattern over and over and over again because it's their charges, it's what's holding them together at that point. That's what the book is trying to show you with the different colors of the green and the gray blocks on page 39, trying to show, okay, that it's all these balls, because basically, again, they just use circles to represent it because of Dalton's atomic theory. That's not quite accurate, but it's just representing it to you. And how it's basically these balls are circled over and over again, they're stacked together to make up a salt cube. So just mean that the deployment unit is just the smallest ratio. Alright, we've already kind of talked about that. Anyone have any questions about that part? Alright, the table, you need to know. We're going to have the quiz over this potentially next Wednesday. So also come I told you about it last week, so I gave you time to talk about it. And that's now the curriculum calls for introducing it on a Monday and then having the quiz on Friday. So I'm trying to give you a weekend in time to study it. So I'm giving you longer than normal. So make sure you are studying and using it properly. Alright, so names of the ions. The cat ions are pretty straightforward. Alright, if it's a cat ion, what type of charge does it have? Ethan.
Positive.
Yep, it has that positive 1. So if more than one version of the cation exists, though, then you include the charge of the cation. How many of the cation on that table have more than one type of charge, though? We already talked about this on Friday of last week.
All of them.
No.
I don't know.
Open your book.
I
Okay.
don't know where you're gonna start. I don't do so I don't
No,
know.
it's okay. Go ahead and get it out. Page 40. Alright, so how many?
None.
Nope.
Huh? One.
Nope. There are 5 elements that have multiple charges. Now keep in mind that if you look at group 1, I'm going to go ahead and slide, so I remember. If you look over and if you look at the table, you will notice that some of them are in group 1. You don't have to memorize it this way right now, but you are eventually. So if you want to go ahead and memorize, hey, these are the elements for the cations in group 1, then go ahead and memorize it. Because if they're in group 1, how many valence electrons or how many electrons do you think they want to lose? We'll talk about reasons why later on, but how many do you think they want to lose?
0. 1.
1, because they're in group 1. We'll talk about the reasons why that works that way. So just make a note of, okay, they want to lose 1 electron. So because of that, they will develop what charge if they lose 1 electron? Chris? If they lose 1 electron?
If they lose one, it's positive.
Yeah, positive what?
Positive charge.
Okay,
Positive
positive 1 to get positive 1 because they lost 1 electron. Remember, number of protons can't change. So if they have 6 protons, they lose 1 electron, then they're going to have a positive 1 charge. So if you look at that list, if you see just a little positive sign off the side, you notice, hey, it lost 1. Like for example, sodium. Na positive, it's Na positive 1. It's lost 1 electron. So if you want to memorize it as the ones in the periodic table in group 1, that they are always positive 1, okay, you're going to have to memorize it that way anyway. So you might as well do it now because it'll save you time and effort. So they're always positive 1. Okay.
Is it possible for an atom to not have a proton?
No. Because the smallest one is hydrogen and it only has 1 proton, so you can't, you don't exist anymore.
Wow.
Alright, so group 2, if you're in group 2, how many valence electrons do you think you want to lose, Ethan?
2.
2. So these will always be positive 2. So again, if you look and you see calcium. Also remember to write on this half of the board because I remember I shifted my camera over. So calcium always has a positive 2 charge because it wants to lose 2 electrons.
Can they see me?
What? Wait, what?
Can they see me?
Yeah. No, they cannot see
What
you.
about me?
No. I have a camera shifted where it's basically over here for it. So, if you want to memorize it that way, that's fine. The only really weird one is ammonium. You have to memorize ammonium. So sorry. H4, positive 1 charge is ammonium. And then you have the 5 transition metals that are different. Those metals where it's copper, iron, lead, magnesium, and tin. Those are the 5 that can have multiple charges based on this chart. There, in the middle, they don't have a straightforward rule for them, so because of them, they can either give up 2 or 1, some cases 3, some cases 4, it just depends. Now sometimes you have to memorize that there's copper 1 and copper 2. In some cases, copper will only give up, now remember what's the atomic symbol for copper?
Cu.
Cu. So copper sometimes will give up 1 electron, sometimes copper will give up 2 electrons. We'll talk about the reasons why later, so don't worry about it. But it's just pointing out that, okay, you can either have copper 1 or copper 2. Because of that, we give the Roman numeral to give the charge. So we would say copper, Roman numeral 1, it's lost 1 electron. Copper number 2, it's lost 2 electrons. That's just how traditionally we name these ionic compounds. So it's not the number of copper atoms. This is not a prefix to tell how many coppers there are. We're saying the charges. Alright, anyone have any questions about that with the cations? Cations are honestly pretty straightforward. Once you get a hold of them and you understand what's happening, they're not that difficult. The anions are a little bit harder. So the anions, you're just going to have to just memorize them. And you just have to memorize which one is which for it. There's not a whole lot of tricks for it. You're just going to have to. So some of them are straightforward, like bromide. So bromine, some of our changes that I need to add. I should not have moved my camera back. Come back over here. So bromine, if you come over here, alright, it's in group 17. So if it's in group 17, anyone want to guess how many valence electrons that it has already?
17.
That's a good guess. I know it feels like that.
16.
Technically, it's just 7.
7.
So you look at the last number for it, 7. We're going to talk about the octet rule. You might remember the octet rule from physical science. They want to have 8 to be happy and to be satisfied. So if it has 7, how many more does it need to be happy, Ethan?
7.
Alright, it has 7 and it wants to have 8. How
Yeah.
many does it, what?
1.
We need one more. That's will come for this one. It's bromide and it has a -1 charge because it's taken 1 electron, it's happy and it's satisfied now. So some of them you'll notice make sense, like fluoride. You'll notice that the ones over here in group 17, they all have a -1 charge because they've taken 1 electron and they're happy and satisfied. Group 16, they have a -2 charge, they're happy and satisfied. Oxygen's the only one that gets kind of weird, but that's the reason why for it. Okay.
So bromine is pretty much, before it gets its other thing, it's pretty much the crust.
Yeah. It wants, we're going to talk about the reasons why with the octet rule, but they want to have 8 valence electrons. We'll talk about why once we get to that chapter, so don't worry about why does it want 8?
If it wants
Wait,
8,
like,
does
where-
it also want like 16 electrons or something? Is that something too?
Okay, this is valence electrons, it's the outermost layer of electrons. So if you have, for example, oxygen, how many protons does it have?
8. No.
Nope, you're right. 8. So how many does it start off with if you have a neutral charge? 8. Now, we're going to talk about it once the valence shell, because of how they fill them in. They fill them in basically with layers, because if you have a negative electron, does it like being right next to another negative electron? They will try to space themselves out. So atoms and the elements, they want to have 8 in that outermost shell, but depending on how they feel, they might not have all 8 there at the same time. So it's one of those, we'll talk about the reason why, so don't worry about it a whole lot right this minute, but that's the reason why they want 8 in that outermost layer.
I feel your pain, bromine.
What?
I feel bromine's pain.
I'm sorry. Alright, but some of them you just gotta memorize. So the polyatomic ions, the ones that have multiple atoms in them, so polyatomic, many atoms, these are enclosed in parentheses if you need more than one of them. So if you look, for example, like acetate, that very first one, what's the charge of acetate? Ethan? Very top of the anion section. What's the charge for a C2H2? Negative 1, 2, 3, 4. Negative 1. So if I were to bond, we'll use copper. So if I were to do this, alright, so if I write it like this, how many electrons, I'm sorry, Jamie, I'm forgetting to slide my thing back over. So if I were to write it like this, how many electrons has copper lost? 2. Can I just say, poof, the electrons are gone, or do they have to go somewhere? They have to go somewhere. So if I were to have copper 2 acetate, the acetate, C2H3O2. Alright, how many electrons can acetate take if it's a -1? Chris?
1.
1. Now, copper wants to lose 2. You can't go 1 to acetate, 1 to infinity. Okay, those electrons have to go somewhere. So because of that, if copper is losing 2, that means there has to be 2 acetate anions to be there. And each one has taken 1 electron, because they can only take 1 at a time. Kind of how, like, whenever you're looking at, this will work for it. This is a binary compound with the same idea for it. Oxygen wants to take how many electrons to be happy? 2. That's will come. Hydrogen will share, or if you want to think of it this way, share very loosely, because hydrogen, each one can only give up 1 electron for the oxygen to be happy and satisfied. Technically, they're sharing very loosely. Oxygen's hugging them at that point, but that's the reason why for it. Alright, so does anyone have any questions about how to do this before we practice? Okay, so your book gives you the example on naming. Your book just tells you that there's an older system and it gets to the top of the page 40, so the old stock system, we don't do it that way anymore, so don't worry about it. So naming the ionic compounds. So you're just naming them off. Again, the cations, pretty straightforward. The anions, you're gonna have to look at your chart for right now to figure out which one is which. Alright, so if I have NaOH, alright. What is the cation? What is the name for this one? Alright, Chris. Hey Chris, this Na. What is this one?
Sodium.
Sodium. Alright, OH. Ethan, you're gonna have to find it in the chart because you probably don't know what this one's name is. Do you remember what? Can you find it and tell me what this one is?
Hold on.
Let's go down to you see OH. It should be on which one?
I don't see it.
Alright, it's in that first kind of block of the anion section. So
Oh, right there.
yep, that's fine. Forget about that one.
Hydroxide. You wanted to say
Hydroxide.
that.
It's okay, hydroxide. Alright, is there more than one version of sodium, Chris?
Yeah. No.
No, so this one you would just say sodium hydroxide. That's it. That's just the name for this particular substance. Just sodium hydroxide. That's all you're doing for it. So once you know the name of your ions, that's it. Alright, do you have a question or was that it?
That was it.
Alright, so let's do the next one. Alright, oops, that is not the right substance.
Okay.
I know they're in your book, don't cheat, because you have to practice. Okay, so we'll start with Ethan. Alright, what is this one? What's the cation? Which one?
Carbon.
It's
Alright,
Ca.
Cu. Oh.
Ca.
Calcium.
Calcium. Alright, and then what is this anion?
Calcium. Penta.
You're thinking of prefixes for the binary
Cobalt.
molecular
Cobalt.
what?
Cobalt.
It.
CO is cobalt.
Oh, see, this is carbon,
Not cobalt.
oxygen 3.
Okay.
So, that's the reason why.
So three?
If
Carbon
it's,
trioxide.
okay, look,
Carbon
if
trioxide.
that
it's
was
CO, wait, stop. If it's CO where the O is lowercase, this is a symbol for cobalt. If it's capital C, capital O, that means it's carbon and oxygen. Okay.
I'm talking about the number. The 5. That was the 5.
I'm sorry. I'll fix it.
Big.
Okay,
Thank you.
so
Carbon
now,
trioxide.
nope, you're thinking off the prefixes over how to name a binary molecular. You have to look at the chart to see what do we call this ion. Let's see. It's the second. If you look at that second box
Is
where
it
it's
carbonate?
carbonate. Yep. All right. Now, can there be more than one version of calcium? Ethan, back to you.
No.
All right. So this one would just be calcium carbonate. That's it. That's all you're doing for it. You don't worry about prefixes because we use prefixes for the binary molecular molecules. These are ions, so the rules of prefixes do not apply to these. So don't try to sound out and figure out if it's carbon trioxide. Nope, nope, nope. We're talking about the whole ion right now. Okay.
So all the quizzes don't have to name.
Oh yeah, basically, and match the charges with them. So it's pretty straightforward. You have to memorize the names. That's why we practice with these, and you just drill them. So every time I have all my cards, we'll start drilling. I want to practice naming them. But then you just start drilling them. So cations, pretty straightforward to memorize. Anions, a little bit harder though. Alright, we'll go back to you, Chris. Alright, so KCN. Alright, the cation is the first one. So what is this?
Potassium.
Potassium. Alright, Ethan, find CN.
Cyanide.
Cyanide. Good job. Alright, so is there more than one type of is there more than one type of potassium? No, so just potassium, cyanide. That's all you're doing. Alright, Ethan, CuCl. Alright, so what is this one, Ethan? Cu.
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 Should have a good one.
Shh, let him figure it out.
Copper.
Copper. Alright, what is this one?
4.
Okay, now this one's a little bit trickier. Is there more than one
Yes,
version of
there is.
copper? Look at it. There's not?
Yes.
There is. Alright, so you have to make sure your charges or the electrons matching up. Alright, if this is chlorine, so chlorine's over here in group 17. Sorry, but Jamie, you was up to one right now. Alright, if chlorine is in group 17, how many electrons does it need added to it to be happy? If it's in group 17, that means it has 7 right now.
10.
It wants to have 8, so how many more does it need?
1.
1. So this chlorine has taken 1 to be happy. So, is this copper 1 or copper 2, where it's given up 1 electron or 2 electrons?
1.
This is copper 1. So we would write out the name and say the name as copper 1 chloride. Alright, you have questions about how to do that? Alright, let's look at the next one then. So, NH4NO3. This one's a funky cation. This is the only one where it's more than one type of element or more than one type of atom. Do you remember this one called?
Nitrogen.
You have to just look at the name for it. It's at the very top of the cation list.
Ammonium.
Ammonium. So this one's just ammonium, and what is this one, Ethan? You're gonna have to just find it in the anion chart. Nitrate. Now, just keep in mind you have nitrate and nitrite, so just be very, very careful. They're very similar. Your book doesn't talk about it, but it's how the O's are bonded to the nitrogen. How come some of them are nitrate and some of them are nitrite, or you'll notice they have that ite or ate ending. There's reasons behind it, and I remember learning about it in chemistry. Your book's just saving time, so they don't explain it. So just make a note that it is important as to which one is which. Alright, so for this one, since this is a polyatomic cation, there is no other version of this one, so it's just ammonium and nitrate. Alright, let's look at the last one then. Alright, we'll go back to you, Chris. Alright, so that's not an M, MgOH, and then there's 2 of them. Alright, so what is this substance?
Magnesium.
Magnesium. Alright, and then what is this one, Ethan? Are this one familiar?
Yep, hydroxide.
Hydroxide. Now, what does this mean if there's a 2 down here? How many hydroxides are there?
1, 2.
2. There's 2 of them. So that's what it's saying, that there's 2 hydroxide anions right here. So, if each one of these is only taking 1 electron, what's the charge of the magnesium total right now then if each hydroxide is taking 1 electron?
Positive 2.
+2. Is there more than one version of magnesium though? No. So you just say just magnesium hydroxide. You just give it like normal. Alright. Anyone have any questions about this? Alright, let's look at the examples at the top of page 41 for this, just practicing again. So it says name the following ionic compounds. So kind of how like we've been talking about, to where you're just saying, okay, here's the substance. Now, how do I figure it out? You have to look at the electrons to figure out, is it copper 1 or copper 2, or how many hydroxides do you need therefore. Alright, so this first one, PbCrO4 for this one. Alright, so how would I name this one? Alright, what is this substance first off?
Tin.
Tin?
No, Pb.
Pb. Nasty sandwich.
Lead.
Lead. Alright, Ethan, you're gonna have to look this one up. Alright, so what is CrO4?
Chromium oxide.
No! It's binary.
Oxide, chromium.
You gotta look it up. Look up to see in the chart. What is that?
Chromate.
Chromate. Alright, now looking at the chromate, how many electrons does it need to be happy? What's that little charge off to the side? Charge is a
4.
-1. What?
It said 4.
And 2 electrons. So how many electrons has lead lost then? 2. Alright, is lead one of the ones where it can have multiple forms? Or is it always just +2?
Oh, it's positive 2.
Is it over here in the +2 column? Sorry, question, Jamie. Is it over here in the column 2, or is it over here in the middle somewhere? It's in the middle somewhere, so can it have more than one type of charge? It can. So, if this one has given up 2 electrons, how do we name it then? Cheater. Now remember, we just say just the charge, or we give the Roman numerals after it. So we just say,
Plumbous ion, or is it lead 2 ion?
lead 2 ion. So, this one you would just say as just lead 2 chromate is how we would name this one. So just lead to chromate. Because you're saying here's the charge because this lead has given up 2. Chromate always takes 2. That's what, no, so you don't have to say that one specific charge for it. Alright, let's look at the next one. Oh, nope, no. Alright, Ethan, what's Fe?
That is Fe is not properly mentioned.
No, it doesn't. It's in Minecraft, I don't know what you. Iron. Alright, what is oxygen? I'm sorry, I said, what is oxygen? Alright, so oxygen can have some funky rules. Oxygen almost always takes 2 though. So you'll notice oxygen has a couple of weird forms. So how many electrons has iron given up then, Chris? 2. So is there more version of iron, or is it always given up 2?
More than one.
Alright, so how would you say this?
Iron 2.
Iron 2, and then what's the oxygen? Change the ending.
Oxide.
Oxide. So iron 2, oxide. Almost like a Alright, you got a question, Ethan?
No, I actually thought about that.
You're done. So yeah, so if you got the answer, good. Alright, the next one is basically the same thing. So alright, this one's a little bit harder though because you have to make the charges match up for it. Alright, so if each oxygen has a -2 charge and there's 3 of them, what's the total charge for the anion side?
3. Wait, what?
Okay, so each oxygen is -2. So I have 3 oxygen. So what's the total charge for the anion side? -6. Alright, now that means that all the oxygens together have taken 6 electrons. So how many electrons have the irons lost then? Total altogether.
1.
Total altogether. If these have taken 6, how many of these lost altogether?
4.
If these have taken 6, so how many do these have to lose then? If these have taken 6?
2.
They've taken 6. How many total electrons have been lost over here? If these have
6.
taken 6. Okay. Yes. Alright, now I think you were trying to think through the next part that there's only 2 irons. So if they have to lose
I don't think I know.
what?
That's what exactly what
I'm saying, alright, so how many did each iron lose then? If there's only 2 of them, but they have to lose a total of 6.
2.
Okay, so there's 2 irons. So 6 divided by 2 is? 3. There you go. So each iron
This is
has
so
lost.
stupid.
I know, you have to just think it through though, because you can't just say
This gives me
electrons
a
just.
headache.
I know, I'm sorry, but it's practice. You have to practice this. So that means that each iron has lost 3 and its oxygen is gained 2. So the total cation side, all of it together, had to lose 6. All of it together, the anion side had to gain 6. You have to figure out if there's only 2 irons over here, how much did each one lose then? Okay, so if each iron lost 3, what's the charge of each iron then? If each iron lost 3 electrons. Yep, positive 3. Is there more than one version of iron, or is iron always 3 plus?
There's more of it.
There's more. So how would I name this substance? Alright, what element is this?
Iron 3 oxide.
Oxide, that's it, that's perfect. Alright, so I know that one's a little bit harder. Okay, do you want to get questions about it? Alright, so to the last one then. So that's still not an MgOH. Alright, alright, that's a really bad G, I'm gonna fix that. Alright, what is this substance? Anything? What is this substance? Should recognize this one. Ethan? I looked at the wrong thing.
Hydroxide.
I'm sorry, we already did this one. Listen to the example for the last one. ZnC2H3O2. I'm going to put it in parentheses so that way you can see it a little bit easier. Oh, and there's 2 of them. Alright, what is this one? Zinc. Alright, what is this substance? You're gonna, yep, acetate. Alright, so how many acetate molecules do I have? Alright, how many does each acetate, how many electrons does each acetate molecule take?
The zinc has a positive 2 charge.
Okay, how do you know that?
Because each single one of the acetate molecules takes each one thing to be added.
Alright, so how would you name the substance then?
Zinc 2.
Is there
No,
more
it's
than
only
one?
one, it would just be zinc acetone.
Close, acetate, this is acetate. Alright, anyone have any, but that's it though. Alright, anyone have any questions about how to name these? Alright, so your book basically walks you through and tries to explain in words of what we've been doing. So mark the italicized phrases on these pages. So on pages 41, and then we already took through 40. Just make a note, the name of the ionic compound consists of the name of the cation followed by the name of the anion. When naming an ionic compound containing an element that can exist in more than one cationic form, a full name must be used according to the stock system, and the charges in the ionic compound must balance. Alright. Okay, we'll talk through this last bit and then we'll roll. Alright, the empirical formula is always the simplest ratio of ions and the results in an equal number of positive and negative charges. We've already talked through that. Polyatomic ions must be enclosed in parentheses. The formula unit includes more than one of the ions. So again, we've already talked through that part, saying that, okay, if you need more than one with a polyatomic ion, you have to put it in parentheses. Alright, let's look at the last example at the top of the next page, and then we should have enough time to drill still. Alright, write the formulas for the following ionic compounds. Alright, calcium bromide. Alright, if it's calcium, what's the symbol for it? Ethan. Ca. Alright, and then bromide.
Br.
Okay, I was putting it there.
Oh,
That's okay.
I thought
Alright,
it was
so Br. Alright, so how many electrons does calcium want to give?
1. 0.
Alright, sorry, Jamie Clinton. Alright,
Oh.
everything group 2 over here.
2.
2! How many does bromide want to typically take? It's in group 17 over here. So if it has 17, it needs 8 to be, so if it's in group 17, that means it has 7, so it needs, and it wants to have 8. So if it has 7 right now, how many more does it need to be happy? 1. So calcium has given up 2. Bromide's only taken 1 though. So how many bromides do I need to balance this out? Because calcium can't go 1 to bromine, 1 to infinity. It has to give it to something. So if bromide can only take 1, how many bromides do I need to balance out the fact that calcium wants to give away 2?
1.
So I only need 1 bromide, or I need 1 more? It can't go shove onto bromine. Bromine
need
only.
1 more.
I need 1 more. So you would write a little subscript of 2, saying, okay, each bromide has only taken 1.
Okay.
But calcium is, I know, this is going to take practice.
Simple.
You're going to use this over and over and over again in the next couple chapters. So get practice with it, so that way it'll hopefully, I'm in study hall with you later, so if you need help, ask me in study hall. Alright, let's look at the next one. Alright, 10,4 oxide. Alright, if it says 10,4, what does that mean?
It's positive charge of 4.
Good job. Alright, you remember what the symbol is for 10?
Heat. No.
That's okay. Alright, SN, so it has positive 4, and then oxide. What's oxide?
This is O.
Yep, so oxygen. Alright, now how many does oxygen typically take? 2, but this is 10.
So it's gonna be 10. It's gonna be 10 dioxide. No, 10 oxygen 2.
Good job. Yeah, that's it. So that way each oxygen has only taken 2, but you're right, then I need 2 of them. So wait, each one gets 2, so it balances out to the 10's 4. Alright, let's look at the last one, Ethan. Alright, so it's almost ammonium. Aluminum sulfate. Alright, what's the symbol for aluminum? Aluminum.
Al.
Al, that's not a name.
Aluminium.
I know, I'm combining them. Aluminum and then sulfate. You guys are gonna have to find sulfate.
Sulfate is on.
Is with them?
It's in the chart, right?
Yeah.
This is not just S.
For sulfate? No. Oh, you're looking at the periodic table? No, it's in the chart on page,
That's what I thought.
sorry, page 40. That's why I'm at my chart.
Very bottom of the island.
Sulfate.
Yep.
SO4.
SO2. Alright, so what's
Also-
the charge of, let's see, what is the charge of, what am I
4.
looking at?
Wait.
Did you say
Also-
SO4 or SO2?
SO4.
SO4.
2 negative.
Thank you.
Also, for other things, also for, get it?
Don't distract. Alright, so what is the charge of the sulfate then?
2.
-2. Alright, what is aluminum's charge? This one, you can memorize because aluminum's almost always this. but even though aluminum is not over here in group 1 or
Yeah.
group 2, this one's always discharged. So you can memorize this one, it's always the same. Remember?
It's always 1.
Nope.
Always 10. Always 7.
It's not 1, it's not 2, it's
7. 6. It's not 1, it's not 2, it's 3.
3. Aluminum's always positive 3, so this one's kind of nice. We'll talk about the reasons why later.
This is
So,
annoying.
if this one is always positive 3, but sulfate can only take 2, what can I do to balance these out? This is going to be well fast.
Add 1 to SF. Right?
So, that becomes -4. Because each one can only take 2. What's the least common multiple of 2 and 3?
1.
What's something that 2 and 3 can both go into?
A lot.
Okay, what's the least common multiple? What's the smallest one they can both go into?
6.
6. Alright, so if this one has a -2 charge, how many of them do I need to equal a total -6 charge? Alright, each one is -2. So how many -2s do I need to equal -6?
3.
3. So you're gonna put a little subscript with 3 down here.
A lot of people don't understand things, Chris.
It's okay, it's okay. That's why we practice. That's why I'm helping you specifically, because Chris acts like he's got it. So we'll find out
He
from
acts
homework
like it.
if he actually gets it.
I don't get it.
Or if he's looking in the book, because I keep seeing his eyes sneak
Yeah,
off the
thanks.
book over
Which
here.
one?
So,
Which part of them am I looking
which
at?
one?
Which part of them am I looking at?
You keep looking over at your book. So we're gonna find out from your homework if you actually know what you're doing or not. So make sure you slow down in your homework and do it properly. So for this one though, so you have a total -6 charge. So each aluminum only has they can only lose +3 or only lose 3 electrons at a time. So for how many aluminums do I need if they can only lose 3?
Yeah, it's 2.
2, yeah. So you get a total +6 charge for the aluminum. So this one again is a harder one, but that's what I was coming to practice to make sure that you both understand what you're getting. Alright, so you understand what's happening?
Kind of.
Good, practice homework. You understand what's happening? Yes, ma'am? Okay, so let's drill for the last couple. Okay, I'll give you your homework and then we'll drill. Alright, your homework. You're going to practice on page 42. Study. Study. That's a side note. Study. And then you're going to practice. You're going to do,
Oh, wait, what?
on page 42, you're going to answer problems. Alright, we'll say A through D for number 1. We'll say A and B for problem number 2. And then A and B for problem number 3, so I can help you out if you get stuck. So for that first problem, problem 1, A through D. Problem number 2, A and B. And then problem number 3, A and B. And then we'll practice one more of it. You're going to have to use the table to figure these out because these are all ions. Alright, you don't really have any reading because this might take a while tomorrow. Study, 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 study. Alright, so what would you call this cation, Chris? We gotta just practice drilling them.
Where's PB?
PB is lead.
So it'd be lead 4.
Good job. Alright, what is this one?
Copper 2.
Good job. Alright, what is this one?
Sodium.
Right.
Sodium 1.
Is there more, is there
No,
more?
it's sodium.
So just sodium. Alright, what is this one?
Hydrogen.
Hydrogen. Alright, we'll leave the anions off right now. You know your anions eventually though. Alright.
Do I have revision in this?
Nope.
Alright, cool.
It's good, the bell's ringing in like a minute.
Magnesium.
Is there more than original magnesium?
5 minutes.
So just magnesium. This class does go to 5 minutes. You might eat it quickly.
Cool.
Alright, what is this one then?
Iron 2.
Iron 2. Good job. Alright, what is this one? I know it's been.
Oh, I know. It's silver 2.
Silver is Ag.
Aluminum. What is H?
Mercury.
Mercury. Mercury. Can you have more than one? Is Mercury 2?
Mercury 2. Alright,
10, 2.
good job.
What does that say?
Cu was positive 1.
So copper 1.
Copper 1. Alright,
Calcium 2.
is there more than one version of calcium?
Calcium.
Just calcium. Alright,
Iron 3.
iron 3. Alright, there's.
Mercury 2.
Alright, so there's
Mercury
two
four.
mercuries, and altogether they have a positive 2 charge. This one's a little bit trickier. So if there's two mercury,
Mercury? Just mercury.
but is there more than one version of mercury?
Yes.
So if this is mercury, if each one only has 1 charge, what's the name for mercury then?
Mercury 2?
If they each only have 1 charge, because there's 2 of them, and each one is giving up 1 electron.
I don't get it. I said Mercury 2 and then I said Mercury. For 1.
Okay, so for this one, you can have mercury with a 2 plus charge, because mercury is weird, or you can have it like this. If you have 1 mercury and it's given up 2 electrons, we call it mercury 2. In some cases, you're going to have mercury where there's 2 of them, and each one of them has given up 1 electron.
Mercury
but
4?
Nope. But whenever we have the charge off to the side like that, you're saying totally what's the charge for the entire cation side. So each mercury has only given up 1 electron, but since there are 2 different versions of mercury, you have to say mercury 1 or mercury 2 or mercury 1, because each mercury has given up.
I had to say Mercury 1.
You have to say mercury 1.
Oh, when I said Mercury, that's what I meant. Like
Yeah,
one
you have to
Mercury.
say, but yeah, you have to say mercury 1 specifically.
Oh.
Yeah, I knew what you meant, but you have to say mercury 1.
That's low key kind of dumb.
It's one of those where scientists are saying, because
So-
there are 2 different versions, scientists want to know, well, which mercury is it? This mercury or this mercury? Because they're going to bond differently.
Scientists definitely are not mathematicians.
Yeah, they are, because they have to know, because for this
But they're
one,
lazy.
no, they're lazy in how they're doing it, because they want to make sure that,
So wait.
I'm gonna tell each other, now keep in mind that it's important, because if you have something like this, you might think, well, what's it matter? This is water, you drink this, it'll kill you. So
Yeah.
scientists want to know which ones you're talking about. So that's how come you have to
Right.
know which one are you talking about, because they act entirely different.
We
Just
don't
don't
have to
think,
say
okay,
mono.
wait, just don't think that they have an extra option, so it's still the same. It'll act entirely differently, but sometimes just want to know, which mercury is it? Mercury 1 or mercury 2? Alright, what was your question?
We don't have to say mono, we have to say 1.
You have to say what?
We don't have to say mono, like 1.
Nope, you say because
But
you're
we have
going
to say
off,
1.
what?
But we have to say 1.
You have to say mercury
That's
1.
so
Well,
stupid.
keep in mind that that's because you're naming 2 different things. Which one uses the prefixes? Naming the ions or naming the binary molecules?
No. Right.
Nope, the binary molecules. That's what comes. This is how
I think that's
scientists
mixed up.
tell each other what type of substance it is. There is logic behind all of it. It's just hard. So that's the reason why we practice
Yeah,
it. though.
yeah.
It's one of those, but you have to learn it because scientists that's how they talk to us. You have to learn it. So I know it's hard. Go get it.
It's like when we're so brain. It's like I need the H2O2 and then
Yeah.
let's kill someone.
They have to know it. All right. So what is this one, Ethan?
Mercury 1.
Mercury 1. All right. Let's get the anions right now. They're hard.
Good.
Just shove them over. Oh, this one you have to know. Alright, this one you gotta have just memorized. What's the name for this cation?
H. Oh, is it starts with an
First name.
A? Is it ammonium?
Ammonium. Yeah. Let's see. This is cation. I'm gonna put this one. Alright, this one.
Is that Z?
Zn.
Z and zinc?
Zinc. Is there more than one version of
Zinc.
zinc? Is there more than one version of zinc?
Yes. No, you're not.
Nope.
Zinc 1.
Nope, just
Zinc.
zinc. Just zinc. Alright.
I get the big thing.
I know. There's only 5 that have charges.
This is so annoying.
You just have to learn it.
Let's do.
That too. Alright, woo.
Silver.
So is there only one
One.
version of silver?
So 1. Silver.
There's only one version of silver.
You only have 1?
You only have
Why
one
you have
silver.
one? Silver.
Just silver. Alright.
Science.
Is there more than one version of silver? Nope. Alright, have a good day. Learn them. You gotta learn them.
I'm gonna go to the office and ask for some headache.
Alright, have a good day.